Hello, Mr. Lesham is here and we are moving to geometric series, not a sequence, a series. What is the difference between a series and a sequence? Remember? Just pause and see. When I say a sequence, I'm basically talking about sequence of number. So this is a sequence. 2, 6, 18, and so on. Just a bunch of numbers. That's what we've been doing since grade 9. We were looking at sequences. What I've added this here is series. A series is when I'm adding these numbers in the sequence. That's a series, that's a sequence. Okay? Alright. So last lesson we worked with arithmetic series. We basically took the numbers in our arithmetic sequence and we added them. And we worked with that formula. This time we're going to work with geometric series. That means you're going to have a geometric sequence and we're just going to add them up. What does it mean geometric? What makes this one geometric? What is a geometric series or sequence?
It's a ratio.
How do I go from, yes, it's equal ratio, right? So how do I go from 2 to 6?
You're not adding time.
I'm not adding, I'm timing by 3. And from 6 to 18, time by 3. I'll constantly time it by 3. Okay, so now let's remind ourselves what's the nth term of a geometric sequence, just because we will need that. We learned that formula a few years back and we had one lesson reminding us again.
I think
okay?
it's a r to the power of n minus 1.
Fantastic. Okay, we've got a times r to the power of n minus 1. A is your first term, r is the what the ratio, it's not the last, it's what I keep on timing. It's the ratio between the second term and the first term, third term and the second term, okay? And n is n, okay? Alright? Now I'm going to show you, well, maybe just give you an example. In this case, what is Tn equal to? Specifically for this 2 times 3 to the power of n minus 1. That's not 10, not just that. That's the general nth term, yeah? If I want to know the 10th term, if I want to know the last term, you're right, we're going to use that. Okay? Now, by the way, just a funny question. Can I write this to simplify that as 6 to the power n minus 1?
No.
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 No. No. Why not? Why not? What? Odd mass. Okay? We get a power before we time it. Okay. Now, what we're doing now is trying to find the sum of the nth term. This is the term, this is the nth term. I want to find the sum of the nth term. In other words, 2 plus 6 plus 18 plus 10 terms. What will be the sum of this? And for now, to begin with, as before, I'm just going to give you a formula. We will practice it and then we'll prove it in a separate lesson. Okay? So we're going to have a r n minus 1, r to the power n minus 1, okay? R minus 1, okay? Now I have to make sure that r is not equal to 1. We'll talk about that. Why is that? But I've got an alternative way of writing it, okay? I can say a1 minus r to the power of n. I just swap those two terms. If I do that, then of course I need to also swap the bottom one. Can we please not do that? Thank you very much. Okay? So if I decided for some reason to have the 1 minus the r to the power of n, then I must do it also at the bottom. Okay, so I swapped it twice, so I didn't make any difference, right? Okay, take a minute, write that down. Oh, hang on, I need to explain what each one is, but you know already. What is the A?
It's
the first term. And R, the constant ratio, and N is N. Okay, let's take a minute here. Okay, so maybe a word about why, first of all, R must not be equal to 1. Why can't R equal to 1? If R is equal to 1, either formula we use, then we've got 0 denominator, it blows up. We say that the series diverge, and I'll maybe explain that a little bit later what that means. But basically we're getting infinities. We don't want infinity. Now, why would you sometimes use that and sometimes use that? When R, as it is here, larger than 1, you often would use that one. We're going to calculate in a second. But sometimes we work with r which is smaller than 1. And now we're going to get a negative number here and here. So when r is smaller than 1, and I'll solve one example like that, then it's easier to use this one. Okay, we will come back to it. Let's start with this. I want to know what is the sum of the first 10 terms. Okay, so what should I write? I want to find out how much all this business is equal. 2 plus 6 plus 18 all the way. So what should I write? 2 times 3 to the power of 10. Yeah. Minus 1 divided by 3 minus 1. As simple as that. And guys, you just put that in the calculator. In fact, put it in your calculator. And I'm going to just steal their answer. Okay? What you get is, big number, 59,048. Just take a minute. Just make sure you're writing it correctly. Right, chaps? Yeah, I've put a new one. Now, as we've been seeing in the last few problems, before you actually find, we are basically asked to find the sum of the first 15 terms, S15, okay? But before we do that, we should really try and figure out what is our R, what do we keep on multiplying, okay? Right, and by the way, the test is going to be more difficult, so we're not going to tell you it's a geometric series, okay? You're going to have to figure out, maybe you think it's arithmetic, you know? How do I go from 10 to minus 5? But no, you need to develop, well, you can test it, okay? How do I go from 10 to 5? Minus 5. Negative a half. 10 times negative a half, minus 5. Minus 5 times negative a half will be positive 5 over 2. So again, we're multiplying by negative a half. In other words, R is equal to? Negative a half. Now, I already told you that when R is smaller than 1, it's better to use the bottom one. Nothing horrible will happen if you use that. It's just you're going to start working with negative numbers. But if you have a number that is smaller than 1, then you see, if you have a smaller than 1, you'll have a negative here. And trust me, you're going to have a negative there as well. So work with the second one, okay? Can I see? Yeah, I can write down. So I'm going to try and find S15. Okay, so the first term, what is A? 10. Time. 1 minus. Okay, what should I write now? Brackets. Negative a half to the power of 15. Okay, I'll put square brackets here. And I divide it by 1 minus negative a half. Good idea to put brackets. And again, here guys, don't try and do it with your, you're going to have power 15, 2 to the power 15, who knows how much it is. Put it in your calculator. In fact, put it in your calculator. These guys are telling me they got 6,67. So just convince you, I want to make sure you can use a calculator, you're qualified to use a calculator. Okay? You are competent in using a calculator. Let's wait. So as we did in the case of our arithmetic series, okay? As we did in our arithmetic, pick it up. We start simply by basically telling you how many terms there are in the series, and then we're moving up. We're moving up in life to level 3 maybe, where I give you a series, but instead of telling you how many terms there are in a series, I tell you what the last term. So if you look at this equation, I don't have anything about the last term. I need the first term and I need the R. Okay? Okay? I can find the first term, I can find the R, but what I don't have is the N. I need to know how many terms. So to know how many terms there are, how would I figure out how many terms there are?
You make 1 over 2,187 equal to the
what?
equation.
Which equation? I've got 2 equations, the blue or the black?
The black.
No, blue.
Okay, remember, the blue equation tells you what is the actual term. The black equation tells you the sum. Now I know that the last term is 1 over 2187. So I'm going to use the nth term equation, the blue equation, to figure out what the n is. Okay, but first off, I have to figure out the r. What am I multiplying by? by a third. Good one, okay? We're timing by a third. Okay? So now I'm going to say, okay, look, I want to know what is the n here. So I'm going to say the Tn, 1 over 2187, is equal to 27 times r, no, I know what r is, times a third to the power of n minus 1. Okay? And now remember we did that last week. Okay? What would be the first step to do here?
I think divide by 27.
Yeah, first of all, get rid of that 27. So we're going to have a third to the power of n minus 1. I need your help here, guys. 1 divided by how much? See if they calculate here.
59,000.
Yeah, here we go. 59,049, right?
Yes.
Is that right?
Yeah.
Okay, now listen to this. Listen to this. This, what we did last week, I showed you how to use logarithm to solve this, remember? Which was a little bit complicated. Now, in fact, I told you, but I showed you, I can't remember if I showed you in a video, but I'll show you now how you can do it without logarithm. You need the calculator, but you know logarithm. And in fact, we've done it. We've done it since grade 10, I think. Okay? We gotta make sure, and I think Ollie told me, we gotta make sure we have the same base, so we can drop it. So we're gonna write it again as a third to the power of n minus 1. And what I want to do is write that 1 divided by 3 to the power of something that will give me eventually 59049. So 3 to the power of what? How would I do it? There is a function on the calculator. Fact. Okay, factor. So what? It's not factorial. It's fact. F-A-C-T. So write down 59049. Write equal. Do it, please, guys. Equal, and then write fact. And what do you get?
To the power of 10.
3 to the power of 10. Now, great. That's good, but it's not good enough. Why is it not good enough? Because here I've got a third to the power of n minus 1. Here I have 1 over 3 to the power of 10. But I want it to be 3.
So you're going to put it in a bracket?
Yes. So this one I'm going to write like this. What is 1 over 3 to the power of 10? I can say 1. Yeah, exactly. Because what is that? Guys, what is that? What is that? That's 1 to the power of 10. What is 1 to the power of 10? 1 time 1 time 1 time 1. It's 1. It's uno. Uno, always uno. Siempre uno. Okay? Are we happy with this, guys? And then we're back in grade 9. What do you reckon? What do we do now? Drop the base. Drop the base. Okay? N minus 1. N minus 1 equal 10. And finally, n equal 11. End of story. Thank you very much. We're moving on in line, guys. Consider the next series. 5 plus 10 plus 20, blah, blah, blah. Okay? Again, you don't even need to read the question. Let's calculate first. So before I look at the question, what should I calculate? What is the? R. What am I multiplying by? What am I multiplying by? 2. Okay, great. I've got the R. Okay, I know also what the A. How many terms add? Not what is the n when the term is 20,000, but how many terms add to give you 20,475. So now, which equation am I going to use? The blue or the black?
Black.
Now we're going to use the black because I know Sn, the sum, they add to 20,475. So I'm going to write, okay, 20,475 is equal to this.
Ooh.
What is A?
Ooh.
5. R to the power of n, so R is 2, I told you, okay? 2 to the power of n minus 1 divided by 2 minus 1. Okay? 2 minus 1 is just 1, so you don't even need to put that in the calculator. Okay? We can't use a calculator because we don't know what n is.
I should.
Okay? So, alright, what should I first do?
So I think you can just get rid of the 2 minus 1.
Multiply the 5. Take the 2 minus 1.
Divide by
I
5.
can't first of all, take the 2 minus 1. So that's just 1. So I'll rewrite it. I normally won't do it, but for you guys, I'm feeling quite nice.
Thank you, sir.
Okay? So I'm going to write that. Now, opening the brackets is not going to... Well, you can actually. You can.
Yeah, so that's what a donkey when you divide by 5.
Correct. You're right. Equal. Okay? So we know donkeys. We're going to divide by 5. That we can elegantly get rid of the 5. And look, this is n to the 5. So I know it's going to be a nice number. It's not a nasty number.
That's grade 5 or something.
We're going to get 2 to the power of n minus 1. No, n minus 1. Just 2 to the power of n minus 1 equal, according to these dudes, 4,096. Okay? And now what should I do?
Now you should take the minus 1 across.
Yeah, so plus 1, 2 to the power of 9, 2 to the power of n equal 4,096.
And now use the fact pattern.
Let's use the fact pattern. Okay?
7.
So it's going to be 2 to the power of n equal 2 to the power of 12. Okay? You can either use the fact pattern, or if you're feeling like you want to just try logarithm. I just want to try logarithm. Okay? Let's see if you remember how to use logarithm here.
So n is equal to...
N is equal to log. What is the base?
Base is 2.
2. The base was 2 here, so it will be the base in the logarithm. 4,096. You'll get the same thing. You'll get 12. Okay?
So it's 97.
97. Yeah. That should be 97. No, that should be 6, but that should be 7 because we added the 1. You're absolutely right.
No.
No, am I wrong?
You are.
Hang on. That should be 4,095, and that will be 4,096. Okay? Okay, here we go. Okay? I'll just pause and solve any problems there. Okay, that will be the end of this lesson. I'll add another video tomorrow. Cheerios.